Hey everyone, and welcome back to my channel. Today, we're going to be talking about the sine law. So, you might remember that with the triangle techniques that we've used so far, as in SOHCAHTOA and Pythagorean theorem, as well as inverse SOHCAHTOA, if you count that, they all work assuming that we have a right angle triangle. But in this triangle right here that I've set up, triangle DEF, this is not a right angle triangle, right? So we can't use any of those techniques to solve. So what we can do is we can use sine law and a few other techniques that I'm going to show you down the road to solve for triangles like this. Sine law basically takes the idea that we've talked about before, where a smaller angle, like angle D, is going to be opposite to the smallest side of the triangle, like side D here. We can say the same thing for the largest angle of the triangle, which is probably going to be angle E here, being opposite to the largest side of the triangle, like side E right here. So what we get is that the ratio between the sine of the angle D and the side D is equal to the ratio between the sine of the angle E divided by the side of E, which is going to be equal to the sine of the angle F divided by the side F. And if we take the reciprocals, basically we flip the formula, we get the same thing here. Now, these two formulas are the exact same formula, they're just flipped. Really, which one you use to solve does not matter. It just makes it more convenient to have your given variable on the numerator, but it's not the end of the world if you use one of these formulas. Okay, so let's get into some example problems. Okay, so we're going to start with this example right here. So you can see that we have two defined angles, one defined side, and one undefined side. So we're going to say that side J is our unknown, and that angle J is going to be 42 degrees. And we're going to call the other one angle and side I. So I is going to be 80 degrees, and side I is going to be 56. So let's start by using our sine law. You might remember that there are two forms. So we have sine of I divided by I is the sine of J divided by J. And we have the reciprocal form of that. So I divided by sine of I is J divided by sine of J. I said earlier that it doesn't really matter which one you use. What we're going to do is we're going to use the one on the right, J divided by sine of J, just because J is the unknown variable. It saves us one step down the line. But if you use the other one, it's not the end of the world. So let's start plugging everything in. So we're going to get 56 divided by the sine of 80 degrees is equal to J divided by the sine of 42 degrees. Okay, so we're going to use a little bit of algebra. We're going to bring the sine of 42 over to the left side. So sine of 42 degrees times 56 divided by the sine of 80 degrees is equal to J. So at this point, you pretty much just plug the number into your calculator. Really, the only important thing that I can say here is to make sure that you are in degree mode. If you're in what's called radian mode, you're going to get a very different answer. So here what I got was about 38 as the side J. So that was a basic application of sine law. So let's go through the following example. This time you can see that B is an unknown angle. So we're going to have B is an unknown. And let's say that we have A as the others. So angle A is going to be 50 degrees. Side A, which is opposite to angle A, is going to be 12. And side B is going to be 15. So we'll start by writing the expression out. So we'll have that the sine of B divided by the side of B is going to be the sine of A divided by the side A. So rearranging to isolate for B, we get that the sine of B is the side of B times the sine of A divided by the side A. So we're going to go ahead and plug everything in here. So this is going to give me that the sine of B is equal to 15 times the sine of 50 degrees divided by 12. other words, that the sine of b is going to be equal to 0.9576. So at this point, you take the inverse sine of both sides. So that's going to give you the inverse sine of 0.9576. So as an answer, you're going to get that b is equal to 73 degrees. Okay, so this triangle right here, you can see that we have an angle of 67 degrees that's known, and then we have two sides. One is of side length 6, the other is of side length 7. So we'll get you to pause the video and go ahead and try to solve this using sine law, and come back here when you're ready. Okay, so in this example right here, we're going to have that the angle Q is unknown. The side Q is going to be 6. We're going to have the side P as 7, and the angle P as being 67 degrees. So we'll start by having the sine of Q divided by Q as being the sine of P divided by P. So we'll isolate for the sine of Q to start. Q times the sine of P divided by P. So here, that's going to give me that the sine of Q is equal to 6 times the sine of 67 degrees divided by 7. So as an answer, that's going to give me that the sine of Q is equal to 0.7890. And you know how this works. We're just going to take the inverse sine of that to get back Q as being 52 degrees. All right, so these next few examples are going to be dedicated to solving more complicated problems using sine law. So you might remember that with sine law, the angle and sides always have to be opposite. But here you can see that we have two sides. We have one angle, but then this angle D isn't actually opposite to any side here. So this is where we're going to start using some of our different techniques to solve. So to start, we're going to have that D is an unknown, and I'm going to call this triangle DEF. So let's say that angle E is equal to 85 degrees. Side F is an unknown. Side D is also going to be an unknown. Side E is going to be, remember, opposite to the 85, so we have 18. And side F is equal to 14. So remember that we have the sine of D divided by D is the sine of E over E, which is the sine of F over F. And we can't solve for D yet because we don't know either the angle or the side. But what we can do is we can disregard this part of the equation and just focus on sine E divided by E is equal to sine F divided by F. Solve for the angle F, which is right here. And then remember, because in every triangle, the three angles are going to add up to 180 degrees. We can subtract 85 and F from 180 degrees, and that's going to tell us D. So kind of an indirect application of the sine law. Okay, let's get into solving this. So the sine of E times F divided by E is the sine of F. Well, here, that's going to give me the sine of 85 degrees times 14 divided by 18 as being the sine of F. So this is going to give me an answer of 0.7748 as being the sine of F, or about 51 degrees is equal to F. So now we're going to write a little bit beside it that 180 is D plus E plus F. So here that's going to give me 180 degrees is D plus 85 degrees plus 51 degrees. Or 180 degrees is equal to D plus, it's going to be 136 degrees. This gives me a final answer of 44 degrees is equal to D. Okay, so here we have this triangle. You can see that we have two angles and one side. And we don't know anything about this triangle other than what's written on the screen. So what we're going to do is solve for everything about this triangle, as in all of its angles and all of its sides. So first off, we're going to give some definitions to the triangle. So let's say that we have L is equal to 50 degrees, which means that the side L is an unknown. We're going to have M is equal to 60 degrees. So that gives me that side M is unknown, and the angle N is going to be unknown, so the side N is equal to 4. Okay, so let's start off by solving for the unknown angle. The reason being, sine law isn't really useful without it, so we're going to go one down here. 180 degrees is L plus M plus N. That gives me that 180 degrees is 50 degrees plus 60 degrees plus N, or 180 degrees is equal to 110 degrees plus N. Subtracting 110 from both sides, I get back that 70 is going to be equal to N. So now we can set up sine law for either case scenario, for L or M. The solution is going to be the exact same either way. So we're going to get M divided by the sine of M is equal to N divided by the sine of N. Now, isolating for the side M, because that's what we care about, we get back that M, and I'm just going to write down, this is step number 2. It's going to be equal to the sine of M times N divided by the sine of N. So here, that's going to give me the sine of M is 60 degrees times 4 divided by the sine of N, which is 70 degrees. So what I should expect here is an answer around 3.69. So M is equal to, let's call it 3.7. And we're going to do the same solution for side L. So we'll have here that L divided by the sine of L is equal to N divided by the sine of N. So this gives me L is equal to the sine of L times N divided by the sine of N, or L is equal to the sine of 50 degrees times 4 divided by the sine of 70 degrees. So just going to plug everything into my calculator there. And it gives me an answer that L is equal to around 3.3. So just like that, we've solved everything about this triangle. Okay, so this example is pretty similar to the last two, in that I want you to go ahead and solve for everything. So pause the video and come back here when you're ready. Okay, so in terms of how we want to name this triangle, it doesn't really make a difference. I didn't specify any convention. So just off the top of my head, we could probably go ahead and use QRS. So let's say that angle Q is 72 degrees. Side Q is 22. Angle R is unknown. Side R is 15. And angle S is unknown. Side S is unknown as well. So we're going to start by solving for our unknown angle R right there. This is going to be done using sine law. So we'll say that the sine of R divided by R is equal to the sine of Q divided by Q. So what I get is that the sine of R is equal to R times the sine of Q divided by Q. And just because I don't have much room on the bottom, I'm going to right beside it. So that's going to be 15 times the sine of 72 degrees divided by side q, which is 22 there. So when I go ahead and I plug all of that into my calculator, I should get that 0.6484 is equal to the sine of the angle r. So I take the inverse sine of that, and it gives me 40 degrees is equal to r. So for step number 2, I can solve for the angle s there. So let's say 180 degrees is equal to q plus r plus s. Well, that gives me 180 degrees is equal to 72 degrees plus 40 degrees plus s. That gets me that 180 degrees is 112 degrees plus s, or subtracting that from both sides, that 68 degrees is equal to s. And finally, I'm going to solve for my third side, s down here. So same application of sine law. So we get that s divided by the sine of big S is going to be equal to sine of q, q divided by the sine of q. So this is going to give me s is equal to q times the sine of s divided by the sine of q, which is going to give me 22 times the sine of 68 degrees divided by the sine of 72 degrees. So when that is computed, we should get that the side s is equal to 21. Okay, so that's everything for the introduction to sine law. Thank you very much for your time, and I hope that you learned something valuable today.